Okay, let's see how you did with the last example. This is going to be a continuous stream, so you may, if you get the last example right, you can just speed ahead to case 2. But for those of you that didn't, let's just walk through this. So we're going to go ahead and change sine cubed into sine times sine squared. That allows us to take sine squared out and put in 1 minus cosine squared. And again, it allows you to distribute that cosine cubed into the parentheses. Oops. And now you can use your substitution technique. So this integral will become negative now because you can see that sine x dx is equal to negative du. And then you go ahead and integrate. And put your cosine back in. Oops. Don't forget to distribute your negative sign. And don't forget it's an indefinite integral, so you need your constant of integration. Okay, so let's look at case 2. Case 2 is when m is even. Before m was odd. Now m is even, but this time n is odd. So there's 2 cases for when m is even. There's when m is even and n is odd, and then there's m is even and n is even. So in the case of m being even, we're going to go ahead and take the cosine, which now has an odd exponent, and we're going to split it into 2 pieces, just like we did with sine previously. So let's just see this example right here. So we have a cosine to the 5th. I'm going to change that into a cosine squared, cosine, cosine. That's so that I could take every cosine squared and change it into 1 minus sine squared. And since there's 2 of them, I'll just put a square on it just to save some space. So now I'm going to go ahead and do my distributing there. I'm going to multiply out 1 minus sine squared squared. My little trick, square the first, square the last, and squish and double. Again, that allows you now to do a u substitution. So if u is sine x, du would be cosine x dx. And this all just covers up really nicely. So I can go ahead and integrate. And replace u back with cosine. Sine. U is sine this time. Okay, It's your turn to try another example, so you can go to the next slide and try the next example. You can pause the video and come back. I'm actually going to do the you try out on this video in a moment. Okay, so if you didn't get this answer right, actually this one's not too shabby, because you can actually just do a u substitution right away, because it's a cosine to the first power. So it was a little bit of a tricky kind of question, because you really didn't have to do any replacing here. In this case, you could have just right away let u be sine of 2x, and then du would be 2 cosine of 2x because of the chain rule. And so then you can see that your cosine 2x dx will be replaced with a half du. So this whole integral will become a half u to the fourth du. So it's actually much simpler than the one that I had done. And then you integrate. And then you replace the u.